Hello everyone, today we are going to study the memory management techniques. The memory management is one of the important tasks of the operating system responsible for managing the computer's primary memory. The memory management task deals with how to execute one or more than one programs in the memory. When the computer system is powered on, a part of the memory is occupied by the operating system. The remaining part of the memory is kept free and is allocated to the programs which are required to be executed. Any program which the user wants to execute in the computer system is first loaded into memory. The operating systems like Microsoft Windows or its variants permit the user to execute more than one program at a time. The simultaneous execution of more than one program is made possible through the multitasking capability of the operating system. The operating system allocates memory to the programs as needed and then reclaims that memory when the program is closed. Earlier in 1980s, the first IBM PC computer had 128 kilobyte of RAM, which by now has grown more than 1,000 times to around 4 gigabytes on a modern desktop system. Also, the programs designed these days are graphics user interface based and consume significant amount of memory. With today's memory intensive programs, good memory management helps to speed up the processing. So, in short, we can define the memory management as a function of the computer operating system responsible for managing the computer's primary memory. The memory management function keeps track of the status of each memory location, either allocated or free. It keeps a list of all the available free memory blocks. The list contains the starting address and the size of the every block which is free and may be allocated to the program requesting it. The status of the free blocks is updated when the memory is freed or unallocated. One of the most primary memory management technique which was used in the old machine was single contiguous allocation technique. In the single contiguous allocation, a part of the computer's memory is reserved for the operating system. The remaining part of the memory is free and is made available to a single application or a program. That means, only one program is allowed to run at a time by the operating system. MS-DOS is an example of a system which allocates memory in this way. An embedded system which is designed for a specific purpose and application also use a single contiguous allocation technique. The single contiguous allocation technique is the simplest memory management technique. The operating system loads the program in a predefined memory area. Another technique next after the single contiguous allocation is the memory management technique called partitioned allocation technique. The partitioned allocation divides the primary memory into multiple memory partitions, usually contiguous areas of the memory. Each partition may contain all the information for a specific job or a task. The memory management consists of allocating a partition to a job when it starts and deallocating it when the job ends. There, the memory management is classified on the basis of types of the partition made in the memory system. The static or fixed partition is defined during the boot time by the operator depending upon the size and the number of programs to simultaneously execute in the computer system. In a static partition, it is known in advance where the program will be loaded in the memory. So, during the compile time, the compiler generates the absolute code and all the memory references are absolute as the fixed starting address of the program in the memory. When it is not known where the program will be loaded, the compiler generates the relocatable code and at the load time only the relocatable code is resolved to contain the actual memory references. If the program changes its location during the execution, the relocatable code is converted to absolute memory references during the execution of the program. The partitioning, as explained earlier, may be static or sometimes it is dynamic also, depending upon the size of the programs to be loaded in the chronological order. The static or dynamic partition demand the programs to be loaded anywhere in the memory after resolving all the address references relative to the new starting memory location wherever the program is loaded. During the execution of the program, any illegal reference made by the program outside the boundary or the partition results in the operating system error. These checks are implemented in the special hardware mechanism designed in the machine. The memory management provides protection by using two registers, a base register and a limit register. The base register holds the smallest legal physical memory address and the limit register specifies the size of the range. For example, if the base register holds 3000 and the limit register is 1200, then the program can legally access all addresses from 3000 through 4199. Next, before talking about the advanced memory management techniques, it is essential to understand the concept of logical and physical address space. The compiler generates the program execution code with the memory references or addresses starting from 0 or 1. The address so generated by the compiler is a logical address, whereas the address actually available on the memory unit is a physical address. The set of all logical addresses generated by the program is referred to as logical address space. The logical address is also known as the virtual address. The set of all physical addresses corresponding to these logical addresses is referred to as physical address space. The virtual and physical addresses are same in compile time and load time address binding scheme. In multi-user or a multitasking environment, the program may be loaded anywhere in the memory as per the available free space. Therefore, the virtual and physical addresses differ in multi-user or multitasking environment. The runtime mapping from virtual to physical address is done by the memory management unit, which is a hardware device. In short, the memory management unit is called MMU. MMU uses the following mechanism to convert the virtual address to the physical address. The value in the base register is added to the address generated by the user process, which is treated as an offset at a time it is sent to the memory. For example, if a base register value is 10,000, then an attempt by the user to use address location 100 will be dynamically relocated to the location 10,100, as we know that the program has been loaded from the memory location 10,000 and therefore, the base register value is set to 10,000. The user program deals with the virtual addresses, it never sees the real physical addresses. Assume in a dynamic partition environment, the programs are allotted in the memory in the sequential order on a first come first basis. The space is reclaimed when the program is terminated. Over a period of time, this leads to a number of small free blocks in the memory. The total of free memory blocks may be larger than the memory required to run a new program sometimes. But still, the program may not be able to run due to the unavailability of a single larger free memory block. This problem is called fragmentation. The fragmentation is of two types, external and internal. The external fragmentation occurs when total free memory space is larger than the program size, but is spread in the form of large number of smaller free blocks, which are in contiguous memory location. The internal fragmentation occurs when the memory block assigned to a program is bigger, program is smaller, leading to a small portion in the memory block free, that is called internal fragmentation. As I explained earlier, the some portion of the memory is left unused as it cannot be used by the another program and therefore, is called internal fragmentation. External fragmentation can be reduced by compaction or shuffling the memory contents to place all the free memory blocks together in a single larger block. To make the compaction feasible, the relocation should be dynamic at the time of execution. In order to eliminate the fragmentation problem, another memory management technique called page memory management technique is used. The page memory management technique divides the computer's primary memory into fixed size units called page frames and the program's address space into pages of the same size. The hardware memory management unit maps the pages to frame. The pages are logical, frames are in the physical memory. The physical memory can be allocated on a page basis while the address space appears contiguous. A program of size 64 kilobytes may be distributed across 16 frames of 4 kilobytes each. The frame may or may not be in the contiguous memory location. The paged memory can be demand paged when the system can move pages as required between primary and secondary memory. The address generated by the CPU in the page memory management technique is divided into two parts. One is page number. Page number is used as an index into the page table which contains the base address of each page in the physical memory. Second is the page offset. The page offset is combined with the base address to define the physical memory address. The following figure shows the paging table architecture. The next memory management technique which is used is segmented memory management technique. The segmented memory management considers the user program as divided into segments or modules. The segments are the areas of the memory that usually correspond to the logical grouping of information such as a code procedure or a data array or a module. The segmentation is a technique to break the memory into logical pieces where each piece represents a group of related information. For example, a data segment or a code segment for each process, the data segment for operating system and so on. The segments require hardware support in the form of segment table which usually contains the physical address of the segment in the memory, its size and other data such as the access protection bits and status. The status indicates whether the segment is modified or unchanged after it was loaded in the memory. The segments are having varying sizes and thus eliminate internal fragmentation. The address generated by the CPU is divided into two parts just like page memory management, but here in the segment memory management the two parts are, first is segment number. The segment number is used as an index into the segment table which contains the base address of each segment in the physical memory and a limit of the segment. Second is the segment offset. The segment offset is first checked against the limit and then is combined with the base address to define the physical memory address. So, what we have studied are two important memory management techniques which map the logical address to physical address space are page memory management technique and segmented memory management technique. The next important memory management technique is to run a program of size larger than that is available in the physical memory. That means, your physical memory size is only 100 kilobyte, but even then you want to run a program of size 500 kilobytes. So, that mechanism is termed as the virtual memory mechanism, also called the swapping. The swapping is a mechanism in which a program can be swapped temporarily out of the main memory to a hard disk drive and then brought back into the memory for continued execution. Therefore, only a part of the program is loaded into memory for execution. The remaining part is loaded only when the reference is made to that part of the program. The memory management technique uses a portion of the computer's hard drive as additional memory. The programs and the data ready for processing are stored in the virtual memory area of the hard drive, sometimes also called the swap file. For example, a program like Microsoft Office has hundreds of features, and if completely loaded in the memory will take up lot of memory and loading will take significant time. Therefore, only a part of the Microsoft Office which contains the most frequently used features is brought in the memory. The rest of the program is kept in the virtual memory. As it requires other pages or segments or modules during the program execution, it retrieves them from virtual memory and writes over the pages in the memory that are no longer needed. The pages in the memory which are modified are first copied to the virtual memory before they are overwritten in the memory by some another page. All pages remain intact in the virtual memory as the computer processes the program. So, any page that was overwritten in the memory can be readily fetched from the virtual memory again when needed. This process, sometimes called swapping, continues until the program finishes execution. The virtual memory allows you to use more memory than is physically available on your computer, but using virtual memory sometimes slows down the machine, because most of the time due to swapping the lot of page transfer takes place from the memory to hard disk drive, which makes the overall execution of the program slower. Most operating system today allows the user to specify the total amount of hard drive space to be used for virtual memory. So, virtual memory is an important memory management technique we have learned today. The next concepts related to the memory management are buffering and spooling. The buffering and spooling are the two techniques used for managing memory to handle slower devices connected to the CPU. As some input and output devices perform slower as compared to memory or CPU, and if the CPU had to wait for these slower devices to finish their work, it may slow down and degrade the performance of the computer system. For example, suppose a user has to print a 50-page document to the printer. Assuming that the printer prints 5 pages in a minute, it would take 10 minutes for the printer to print a document of 50 pages. The CPU cannot be booked for one printing task for 10 minutes. To avoid this problem, most operating systems use two techniques, buffering and spooling. A buffer is an area in the memory to hold the data transmission from or to the input or output devices. For instance, a keyboard buffer stores a certain number of characters as they are entered via the keyboard, and a print buffer stores the document that are waiting to be printed. The process of placing data in the buffer so they can be retrieved by the appropriate device when needed is called spooling. The most common use of spooling and buffering is for printing jobs. It allows the multiple documents to be sent to the printer at one time, and they will print one after the another in background while the computer and user are performing other tasks. The documents waiting to be printed are set to be in the print queue, which designates the order the documents will be printed. By using buffering and spooling, we can perform the print or the other tasks in the background, so that the CPU is available for the other purposes in the foreground. So, what we have learned today are the various memory management techniques. In a single user operating system like DOS, the programs are loaded from a specified memory location. In an operating system like multitasking and multi-user environment, the multiple programs are simultaneously under execution, requiring sophisticated dynamic memory management techniques like dynamic partitioning, paging, segmentation, virtual memory, or the combination of these techniques is commonly used in modern desktops, servers and mainframes. Thank you.